implementation of Eigrp Equal and Unequal cost load balancing. My name is Kedar Dandekar and I am a Cisco certified Network expert in enterprise infrastructure. So if you have any question, then please feel free to mail me on kedardanekar@nittraining.in. So our first task is to configure the Eigrp classic configuration on all the routers. So let's start with router 1. So on router 1 we have to advertise the LAN 1 network 192.168.0.0. Also the remaining networks are 200.100.0.0, 2.0, 4.0, 6.0 and 8.0. After that router 2. So on router 2, 200.100.0.0, 1.0. Now router 3. So on router 3, 200.100.2.0 and 3.0. After that router 4, 200.100.4.0 and 5.0. After that router 5. On router 5, 200.100.6.0 and 7.0. Now router 6. So on router 6, 200.100.8.0 and 9.0. After that router 7. So on router 7, LAN 2 network 192.168.1.0, LAN 3 network 2.0 and the remaining networks are 200.100.1.0, 3.0, 5.0, 7.0 and 9.0. So we have done the Eigrp on all the routers. Now after that the second task is to configure the route tagging on router 7, so that for the network 192.168.1.0 tag must be set to 100.100.1.1 and for the LAN 3 network 192.168.2.0 tag must be set to 100.100.2.2. So we have to configure this on router 7. So on router 7 first we have to create the access list. So in access list first we will match the LAN 2 network 192.168.1.0. We will create the second access list in which we will permit the LAN 3 network 192.168.2.0. So we will create the route map. So in route map now we will apply the first access list and now we will set the tag to 100.100.1.1. We will create the second statement and in this second statement we will match the second access list. We will set the tag to 100.100.2.2 and now we will apply this route map. So let's clear the Eigrp neighbors also. So after clearing, now we will verify this on router 1, show IP route 192.168.1.0. So here we can see that the route tag is not showing into the dotted decimal format. So for that now we have to give the command route dash tag notation dotted dash decimal. Now let's verify it again. Now here we can see that for 192.168.1.0 the tag is set to 100.100.1.1 and for 2.0 the tag is set to 100.100.2.2. Now after that the third task is to configure the Eigrp equal cost load balancing on router 1, so that when he will send the traffic towards LAN 2 and LAN 3, then he must use all the 5 paths with equal cost load balancing. Also router 1 must take all the 5 paths in the routing table. Also we have to configure the per packet load balancing on router 1. So this is my router 1. So when he will send the traffic towards LAN 2 and LAN 3, then he must use all these 5 paths. Also he must take all these 5 paths in his routing table. Okay, so for that now let's verify the topology table first on router 1. So IP Eigrp topology. So here we can see that for LAN 3 network 192.168.2.0, so in topology table router 1 is having 5 paths and all the paths are having different metric value. Same thing for the LAN 2 network 192.168.1.0, router 1 is having 5 paths and all the paths is having different metric value. Okay, and now the first path, the path via router 2 200.100.0.1, this path is having lowest metric value. Same thing for LAN 2, this path is having lowest metric value. That's why router 1 will select this path as a best path. So if you verify the routing table, so we can see that for LAN 2 and LAN 3, for both the networks, router 1 is selecting the path via router 2 because it is having lowest metric value. But the task is saying that router 1 should use all the 5 paths with equal cost load balancing. Okay, so for that now what we have to do? So in previous task we have already matched the tags. So we have already set the tag for LAN 2 and LAN 3. Okay, on router 7 now we will match those tags on router 1 using route tag list. So we will match 100.100.0.0 and 0.0.255.255. Okay, and now we will create a route map, permit 10, and now we will match the tag list, and now we will set the metric. Now what router 1 will do? Router 1 will match those network that is having the tag starting with 100.100. So our LAN 2 and LAN 3 network are having the tag starting with 100.100. So now router 3 will set this metric for LAN 2 and LAN 3 networks. So let's apply this route map now. Let's clear the Eigrp neighborships also. So now if you verify the topology table again on router 1, so now we can see that for LAN 3 network, so for LAN 3 network router 1 is having total 5 paths and now all the 5 paths are having the same metric value. Same thing for LAN 2 network, all the 5 paths are having same metric value. Okay. Now if we verify the routing table on router 1, so now we can see that for LAN 2 and LAN 3 network, router 1 is only taking 4 paths in his routing table. Okay, but now in topology table we have seen that all the 5 paths are having the same metrics. All the 5 paths are having the same metric. Then also router 1 is taking only 4 paths in his routing table for both LAN 2 and LAN 3 network. So why? Because Eigrp by default will take only 4 paths in his routing table. Okay, so now if we want to take 5 paths, then we have to give the command router Eigrp tell maximum dash path 5. So now after giving this command, now router 1 will take all the 5 paths in his routing table. So now we can see that router 1 is taking all the 5 paths and all the 5 paths are having the same metric value. Okay. So now let's try to ping it from PC1 to PC2, LAN 1 to LAN 2. Ping 192.168.1.1. So we are getting the reachability. Now let's try to trace. So now we can see that the traffic is going from 200.100.0.1, that means from router 2. If we trace it again, now it is okay. So you forgot to configure the per packet load sharing on router 1. So let's configure the per packet load sharing. So we have to configure it on all the interface E0/0-3, E1/0. So IP load sharing per packet. Now let's try to trace it again. So after giving this command, now we can see that now the traffic is going from 200.100.0.1, that means from router 2. Now it is going from 8.1, that means from router 6. Now it is going from 6.1, that means router 5. Now it is going from 4.1, that means router 4. Now it is going from 2.1, that means router 3. So we have configured the Eigrp equal cost load balancing. Now after that the fourth task is to configure the Eigrp unequal cost load balancing on router 7. So that when router 7 will send the traffic towards LAN 1, then he must only use the path that is having the metric value less than 6,19,000. Okay. Also we have to configure the per packet load balancing on router 7. So this is my router 7. So when this router 7 will send the traffic towards LAN 1, then he must only use the path that is having the metric value less than 6,19,000. So if we verify the topology table on router 7, so here we can see that for LAN 1 network 192.168.0.0, router 7 is having total 5 paths, and from this 5 path we can see that the first path, so this first path is having the metric value less than 6,19,000, so it is having something 3,09,000. Second path is having 3,10,000. Third path is also having 3,10,000. The fourth and fifth path are having the metric value higher than 6,19,000. Okay, so now if we verify the routing table also on router 7, so now on router 7 we can see that router 7 has selected only one path. Okay, so that is going from router 2 200.100.1.1. Okay, so this first path. Okay, but the task is saying that router 7 should use all the path that is having the metric value less than 6,19,000. So actually router 7 should use all these 3 paths. Okay, because all these 3 paths are having the metric value less than 6,19,000. So now for that we have to use the variance command. So router Eigrp 10, and we will give the variance multiplier by 2. Okay, so now in routing table we can see that the best path is having the metric value 309760. Okay, so this is the 309760, and if we multiply it by 2, then we will get the value around 6,90,520. Okay, so now what router 7 will do after configuring this variance 2 command, router 7 will only select the path that is having the metric value less than 6,90,520. That means these 3 paths. Okay, so let's configure this and we will verify it again. So if we verify it again, now we can see that router 1 has selected all those 3 paths that is having the metric value less than 6,19,000. So after that, now these 3 paths are 5.1, 3.1 and 1.1. That means 5.1, 3.1 and 1.1. So on all these interfaces we have to configure per packet load balancing now. So interfaces are E0/0, E0/1 and E0/2. So IP load sharing per packet. So now let's verify it again from, so we will try to ping from PC2 to PC1. So ping 192.168.0.1. So we are getting the reachability. Now we will trace the path 192.168.0.1. So it is going from 1.1 now. So 1.1 means it is going from router 2. So we will trace it again. Now it is going from 5.1. So now it is going from router 4. And now we will trace it again. Now it is going from 3.1. That means it is going from router 3. Okay. So we have configured the Eigrp equal cost load balancing. Okay. So thanks for watching the video. So if you have any question, then please feel free to mail me on kedarthandikar@nittraining.in. Thank you.